Welcome, space enthusiasts, to this exciting presentation on Chandrayaan III, India's incredibly ambitious lunar mission.
3, 2, 1, 0. Plus 5 seconds.
Lift-off normal.
Here
tracking.
we have a majestic liftoff of LBM-3 M4 rocket carrying India's prestigious Chandrayaan III spacecraft.
In this video, we'll launch our own journey to explore the details of Chandrayaan III, its objectives, its technology, and the impact that it'll have on India's space program and the world at large. So let's begin our lunar journey. Before we leap into the specifics of Chandrayaan III, let's take a brief look at its predecessors Chandrayaan I and Chandrayaan II. Chandrayaan I, launched in 2008, was India's first lunar mission that significantly contributed to our understanding of the moon's surface and the presence of water molecules on it. Then Chandrayaan II, launched in 2019, attempted to further advance our lunar exploration efforts with a more complex mission that included an orbiter, lander and rover. While the lander Vikram unfortunately faced a hard landing, the orbiter continues to successfully orbit the moon and conduct scientific observations.
Thousands of people from across the country came together for one dream: India's next big expedition. We're all set. Are you?
Now let's move to Chandrayaan III, India's latest leap in lunar exploration. Let's look at some of the most important facts surrounding the launch. The Chandrayaan III spacecraft was successfully launched on the 14th of July 2023 at 14:35 hours from the Satish Dhawan Space Center. At the time of publication of this video, the launch was a success and the module is currently en route to the moon. It is planned to land on the moon in August 2023. Ritu Karidal Srivastava is the Indian scientist and aerospace engineer leading the Chandrayaan III mission. Known as the Rocket Woman of India, Ritu is an ISRO scientist and a native of Lucknow, Uttar Pradesh. She holds an MSc from Lucknow University in physics, in addition to having also studied at the prestigious Indian Institute of Science in Bengaluru. There were several manned missions to the moon during the United States Apollo program. Apollo 8 was the first crewed mission to enter lunar orbit in December 1968, and it was followed by Apollo 10 in May 1969. 6 subsequent missions landed humans on the moon, beginning with Apollo 11 in July 1969, during which Neil Armstrong became the first person to walk on the moon. Although both the Soviet Union and China have landed rovers on the moon and returned them safely, only the United States have landed people on the moon. India, however, is planning to send a human mission to the moon in the next few decades, and Chandrayaan III will help to pave the way for this mission. There are a few reasons why Chandrayaan III is taking 40 days to get to the moon, which include the trajectory chosen by the ISRO, the limitations of the launch vehicle, and the need for precision. So let's look at these in more detail. The trajectory chosen by the Indian Space Research Organisation is a slower, more gradual trajectory for the Chandrayaan III than the direct translunar injection used by the Apollo missions. This is because the Chandrayaan III spacecraft is carrying a heavier payload, and the slower trajectory allows it to conserve fuel. The Chandrayaan III spacecraft was launched aboard India's geosynchronous satellite launch vehicle Mark III, also known as GSLV Mark III, which is a heavy lift vehicle capable of placing about 8 metric tons into low Earth orbit. However, this vehicle is not powerful enough to launch Chandrayaan III directly to the moon. The Chandrayaan III lander is designed to soft land on the lunar surface, and this requires a high degree of precision. The slower trajectory allows ISRO to make more precise adjustments to the spacecraft's course as it approaches the moon. The primary objectives of Chandrayaan III are threefold. Objective number 1. Achieve a soft landing on the Moon. Chandrayaan III aims to achieve a successful soft landing on the lunar surface, building on the lessons learned from Chandrayaan II's landing attempt. This landing will pave the way for more intricate lunar missions in the future, including further space exploration. Objective number 2: surface exploration. Once safely landed, the mission will deploy a rover to explore the Moon's surface. The rover will carry a suite of scientific instruments to analyze the lunar soil, rocks, and search for water and minerals. These investigations will help scientists to understand the Moon's geology and possibly discover resources that could aid future lunar missions. Objective number 3: enhanced orbital studies. While the focus is on the landing and the rover operations, Chandrayaan III will also have an orbiter component. The orbiter will study the Moon from an advantageous position, enabling high-resolution imaging and conducting remote sensing observations. Part 3: the Chandrayaan III Lunar Module. This complex and sophisticated spacecraft has been designed to enable India to conduct a variety of scientific experiments on the Moon, so the successful launch and deployment of the Lunar Module will be a major milestone for the Indian Space Research Organisation and really help pave the way for future missions to the Moon. The 4 components of the Lunar Module work together to allow the spacecraft to land safely on the Moon and to explore the lunar surface. The propulsion module provides the necessary thrust to carry the spacecraft into lunar orbit. The lander provides a soft landing on the Moon. The rover allows for exploration of the lunar surface, and the intermodular adapter cone provides a mounting structure for the lander and a number of other systems that are used to control the lunar module during its journey to the Moon. Now that we know the mission's objectives, let's take a closer look at these components, the spacecraft responsible for achieving these goals. The launch vehicle. Chandrayaan III will be launched aboard India's most powerful launch vehicle, the GSLV Mark III, also known as the Geosynchronous Satellite Launch Vehicle Mark III. This launch vehicle has proven its capabilities in previous missions and will provide the necessary thrust to send the spacecraft on its journey to the Moon. However, as mentioned previously, this launch vehicle has its limitations and therefore cannot launch Chandrayaan III directly to the Moon. The orbiter. The orbiter component of Chandrayaan III will play a crucial role in facilitating communication between the Earth and the lander rover module during the journey to the Moon. Once in lunar orbit, the orbiter will also perform scientific observations, mapping the lunar surface and analysing its composition. Lander rover module. The heart of Chandrayaan III is the lander rover module, designed to achieve a soft landing on the lunar surface and conduct surface operations. The lander will carry the rover and be responsible for its descent and touchdown on the Moon. The lander is planned to soft land on the lunar surface near the South Pole. Rover. The rover aboard Chandrayaan III will be an advanced version of the rover planned for Chandrayaan II. It'll be equipped with state-of-the-art scientific instruments, including cameras, spectrometers and seismometers, to study the lunar terrain and conduct experiments. When the rover finally deploys from the lander, it's intended to travel up to 500 meters on the lunar surface. That's if it gets there. So, how hard can it be? Technological challenges. As you can imagine, the journey to the Moon and conducting successful lunar missions is no small feat. Just ask the astronauts of Apollo 13.
Houston, we've had a problem.
Undoubtedly, the Chandrayaan III mission comes with its own fair share of technological challenges. The lunar landing. One of the most significant challenges is achieving a soft landing on the lunar surface. The Moon's irregular terrain, reduced gravity, and lack of atmosphere make this a daunting task. Drawing from the experiences of Chandrayaan II, engineers and scientists have meticulously analysed the data to improve the landing sequence and increase the chances of success. Thermal management. The extreme temperatures on the lunar surface pose a challenge to the spacecraft's design and operation. The lunar night can see temperatures plummet to around -180 degrees Celsius, while the lunar day can reach a scorching 130 degrees Celsius. The spacecraft must be equipped with effective thermal management systems to protect its delicate instruments and systems. Communication. Maintaining a reliable communication link between Earth and the spacecraft during the entire mission is essential. The vast distance and interference caused by lunar terrain can disrupt the communication signals. Advanced communications technologies are integrated into the spacecraft to ensure continuous data transmission. The global impact. Chandrayaan III is not just a mission undertaken by India. It's a part of the broader global effort to explore the Moon and to expand our understanding of the cosmos. Collaboration and data sharing with international space agencies including NASA, the European Space Agency or ESA and others will enable the scientific community to gain a more comprehensive perspective of the Moon. However, it's also an opportunity for India to demonstrate its technological prowess in the field of space exploration. The successful landing of Chandrayaan III on the lunar surface would make India only the fourth country in the world to achieve this feat after the United States, Russia and China. This mission also highlights the profound impact of space exploration on humanity because Chandrayaan III represents not only India's dedication to scientific advancement, but also to our shared desire to explore the unknown and push the boundaries of human knowledge. Here at Global Insight, we wish Chandrayaan III the best of luck on its lunar odyssey in the hope that it brings us closer to unlocking the secrets of the Moon and beyond. Thanks for joining us on this journey into the realm of space exploration. If you've enjoyed this video, make sure to like, subscribe and hit the notification button to stay tuned for more exciting content. Until next time, keep looking to the skies.